Hello everyone and welcome to my channel Easy Maths. As you know, I keep on making different videos in maths on different topics. So if you really like to know about those topics in maths and if you really like to watch all of my videos, do subscribe to my channel and don't forget to press the bell icon. Now the topic which I'm going to discuss today is triangles. I'll be starting with a very simple explanation of triangles. This is for those who have no idea about triangles. So I will start from the grassroots level. Now as you can see, I have drawn different kinds of triangles on the board. Now before talking about this kind of triangles, let me just tell you very simply what a triangle is. A triangle is a plane figure, that is, it is drawn on some plane surface. As you can see, I have drawn it on this whiteboard. Like you can draw a triangle on your copy or on a sheet of paper, whatever it is. So it is actually a plane figure. Now what kind of a plane figure is a triangle? It is a plane figure which is bounded by three straight lines. Bounded by three straight lines. That means we have three straight lines which are bounding an enclosed area. Okay, so you can see any triangle is like that. We have other kinds of plane figures also, like we have a rectangle, we have a square, we can have a quadrilateral, we can have a pentagon, hexagon, anything. Those are also plane figures, but those are different kinds of plane figures because the number of sides vary. Here in a triangle we have three sides in each and every case. Now let's see, why have I drawn so many types of triangles over here? There's a reason. I want all of you to look at the first three triangles which I have drawn. The first three. Now if you're studying in class 4 or 5 or maybe even class 6, that is, you are at a beginning level of geometry, then you will see in your books most of the triangles which you will get, which are drawn in your books, are either of these three kinds of figures. That is, what I want to say is, they look like this. That is, we have something called the base, okay, which is drawn like this. The triangle figures which you will see in your book will hardly be like the next three type. They will be like this. That is, one line will always be horizontal like this. The other two lines can be in any position. Now we come to the next three types. Now why have I drawn these figures? In the beginning level, as I said, if you are studying in class 4 or 5 or 6, these kind of triangles you will generally not find in your books. But if you go to higher classes, you will even find these kind of triangles, which are, placed in a different way or oriented in a different way. Now why have I drawn all together? To make you realize from the beginning that triangles can not only be like this, but triangles can be like this also. Okay, it can be in any position. You just need to have a plane figure which is bounded by three sides. That is what you have to keep in your mind. Now as you can see, I have again drawn a triangle. Now you can see that this triangle has got three letters on the three vertices. Now what do I mean by vertices? Vertices are nothing but the corners of the triangle. Like this is one corner, this is one corner, this is one corner. Now each corner is called a vertex. Now when we go to the plural form of the word vertex, it becomes vertices. So since any triangle has three sides, so naturally it will have three vertices. Now we name the vertices like this with capital letters. That has been the convention and that should be followed. I have written here A, B and C. So the name of this triangle is ABC. You could name a triangle in a different way also. You could call like this, you could have written PQR. So that would have been triangle PQR or XYZ. But any three English alphabets you can use. So there is no issue on that. But what you must understand is, here the vertices are A, B, C. These are called the vertices of the triangle. Now we have the sides. Sides are AB, BC, CA. So these are the three sides of the triangle. This is the side AB, this side is AB, this is BC and this is CA. I think it is pretty clear for you to understand. Now we have something else. We have a point like this. Suppose I draw a point like this and I call it X. Now as you can see, I have drawn the point X inside the triangle. So X is a point inside the triangle. If I draw any point like this here on the side AC, or I could have drawn it on any side. Suppose I name it Y. So Y is a point which is on the triangle. Now suppose I keep a point Z over here. So Z is a point which is outside the triangle. So this is a very simple concept, but everybody should remember this. Now we have something else. So let's move on to that. Now as you can see, I have drawn 3 arcs over here inside the triangle. Now arcs are small curves. Okay. Now why are these arcs drawn? These arcs represent 3 angles of the triangle. Now here you can see this arc. Here an angle is formed. Here an angle is formed. So this angle, if you see closely, this angle is inside the triangle. Same with this angle. This is also inside the triangle. Same is true for this angle, which is also inside the triangle. Now, so these are called the interior angles. A triangle has actually 3 interior angles because they lie in the interior part of the triangle. Now we also have something called the exterior angle. Now what is the exterior angle? I will draw and show it to you. Suppose I extend this side what I have done is I have just extended one side of a triangle and I have used this arrow symbol to represent that this is a part of a straight line. Actually it's representing a ray over here, but this is a part of a straight line. Now when I extend this side BC of this triangle, what we get here, this is called the exterior angle of this triangle ABC. Or should I say this is called an exterior of the triangle ABC, because the triangle ABC can have many exterior angles. So this is one exterior angle. If I would have extended the side AC in this way, this side, then we would have got another exterior angle here. I would have done the same on this side, that is CB produced backward. So I would have got another exterior angle over here. So like this way, if we produce any side of the triangle, we would get many exterior angles. Now in one triangle, how many exterior angles could be formed, that I am not saying, that I am giving you as a homework. Please do it, and please do write in the comment section how many exterior angles can one triangle have. But one thing is clear, that one triangle can have only 3 interior angles. Now let's come to how do we name these angles. Now an angle can be named in more than one way. Like in this is a very simple figure. In this figure, when we talk about the angle A, we are actually talking about the interior of the angle A, that is the interior angle A. So we give this symbol to represent an angle. Now after this symbol is written, we write A, and this is read as angle A. Similarly, we can have angle B and also angle C. Whenever we talk about angle A, angle B, angle C, generally we mean the interior angles. We don't mean the exterior angles, because whenever we have to write the exterior angle, we write exterior angle. That is, we write either in short EXT for exterior. For example, this angle which is formed outside, that which is the exterior angle, this is called as exterior angle C, because this angle C is formed over the exterior side of this triangle. but generally when we write simply angle C like this, that means the interior angle of this triangle ABC. I hope till now it is clear to all of you. Now we come to a very basic property of a triangle. This property is called the angle sum property of a triangle. The angle sum property of a triangle. Now we have already learnt, and as you know, that a triangle has three interior angles. Here I have denoted them with A, B and C. Now you know that an angle is always measured in degree. Okay, though we have other units to measure angles, but that is not of concern to us now. We must know that any angle is measured in degree. Now angle sum property of a triangle, this says that in any triangle, please note this, in any triangle the sum of the three interior angles is always equal to 180 degree, or is, you can say in other words, is always equal to two right angles. That is, angle A plus angle B plus angle C equals to 180 degree. This will always be true for any triangle. If I draw another kind of a triangle here, suppose like this, say X, Y, Z. This triangle is smaller than this triangle, as you can see, but here also angle X plus angle Y plus angle Z equals to 180 degree. So this is true for any kind of triangle. If you add the three interior angles, the result will be 180 degree. Now one point must be noted here, because I have seen different students having some misconceptions on this. It is said in the angle sum property that the sum of the three interior angles is 180 degree. Now if this is given to you, or if you know this, now if I ask you a question, in this triangle ABC, we know that angle A plus angle B plus angle C is 180 degree. Can you tell me what is the value of angle A only? The answer to this I am giving to you. With this information, it is not possible to say. Please mark what I am saying. The sum of the three interior angles is 180 degree. That is, angle A plus angle B plus angle C plus equals to 180 degree. But we know this, but whether angle A, what is the value of angle A itself, that is not known to us. Okay, with this information. Similarly, angle B, what is it? We don't know. What is angle C? That we don't know. So we know neither of angle A or angle B or angle C, but we know what the sum is. That is, the sum is always 180 degree. Okay, so this is the angle sum property of a triangle. We now come to types of triangles. Now here again I have drawn three triangles. Now I am going to discuss types of triangles based on their sides. Now we can have types of triangles based on sides as well as based on angles. Now the types of triangles based on angles, that I will discuss later on. So first I start with types of triangles which are based on sides. Now let's see the first type. This is called an equilateral triangle. An equilateral triangle. What does that mean? I said these are the types of triangles based on sides. So an equilateral triangle is a triangle all of whose sides have the same length. That is, this side, this side, this side, all are same. For example, suppose this is 6 centimeter, then this is also 6 centimeter, this is also 6 centimeter. If this is 3.5 centimeter, this is also 3.5 centimeter, this is also 3.5 centimeter. So we see that when all the three sides of a triangle are equal, we call it an equilateral triangle. We now move on to the next type of triangle. This is called an isosceles triangle. Now what is an isosceles triangle? An isosceles triangle is a triangle whose two sides are equal. Now we move on to the third type, that is It is called scalene triangle. Scalene triangle. This is that type of a triangle where none of the sides are equal to one another. Okay. For example, a triangle whose sides are 3 centimeter, 4 centimeter, 5 centimeter, that can be a scalene triangle. So none of the sides are equal to one another. Now there is something to be noted about the definition of an isosceles triangle. It is said that in an isosceles triangle, two sides are equal, whereas it is said in an equilateral triangle, all the three sides are equal. Now there is something very important to note down here. In an isosceles triangle, two sides are equal, but nothing is said about the third side. It is said that two sides are equal. Now somehow even if the third side becomes equal, then also it will be an isosceles triangle, because in that case also the condition that two sides are equal, that is followed. I hope it's clear to you. That means an equilateral triangle where all the three sides are equal is also an isosceles triangle, because here also two sides are equal. Now in an isosceles triangle, the third side may be equal, may not be equal. In an isosceles triangle, if the third side is unequal to the equal two sides, that is if the third side is unequal to each of the equal two sides, then obviously this is an isosceles triangle. Even if it is equal to the two sides, that is even if it is an equilateral triangle, then also it is an isosceles triangle. So one thing can be concluded from this, that every equilateral triangle is also an isosceles triangle, because here two sides are equal. But every isosceles triangle may not be an equilateral triangle, because the third side may be unequal. Okay. And a scalene triangle, I've already told that none of the three sides are equal over here. Now we move on to the next subtopic. Now here again I'll discuss types of triangles, but this time the types are based on angles of the triangle. Previously I discussed types of triangles based on the sides of the triangle. Now the types are based on angles of the triangle. Now let's see, the first type is called an acute angled triangle. Now before learning about the types, I think you have a pretty clear idea about what is an acute angle, what is an obtuse angle, and what is a right angle. So an acute angle is an angle whose magnitude or value is less than 90 degree. A right angle is an angle whose value is equal to 90 degree. And an obtuse angle is an angle whose value is greater than 90 degree but lesser than 180 degree. So this knowledge is required. Now let's see, we have an acute angled triangle. So an acute angled triangle is that kind of a triangle, all of whose interior angles are acute angles. That is, this is an acute angle, this is an acute angle, and this is an acute angle as well. That is, all the three angles are acute angles. Next we move on to this type of triangle, which is called a right angled triangle. A right angled triangle. Now this is, as the name suggests, you can understand, this is a type of triangle, one of whose angles is a right angle. Okay, that is a right angled triangle. You can see here, this is the symbol of a right angle. So in this triangle, this angle which I am pointing at, this angle is a right angle. We move on to the third one, which is called obtuse angled triangle. Again, as the name suggests, here one angle is an obtuse angle. As you can see, this angle where I am pointing at, this angle is an obtuse angle. Now one thing must be kept in mind, when I am defining acute angled triangle, I am saying all the three angles of the triangle are acute angles. Now when I am saying right angled triangle, I am saying one angle is a right angle. Similarly, when I am saying an obtuse angled triangle, I am saying one angle is an obtuse angle. Why? Here in this case all the three are mentioned, here 1 is mentioned and here also 1 is mentioned. Why this is so? Because you must remember that every triangle has at least 2 acute angles. Every triangle which can be possibly drawn will have at least 2 acute angles. This is a property of a triangle. So we see all of these triangles, they will be having 2 acute angles. Let's see, like in this acute angle triangle, obviously there are 2 acute angles. Actually there are 3 acute angles. So in this right angle triangle also there will be 2 acute angles. So here is one acute angle, here is one acute angle. Okay. In an obtuse angle triangle also we see this is an acute angle, this is also an acute angle. So you see, in any way you draw a triangle, there must be at least 2 acute angles. That is why the definitions of these types of angles are like this, that in case of acute angle triangle you must say that all 3 are acute angles, because we already know that 2 will be acute angles. So the third one must be an acute angle. The third one must be an acute angle to be, for this to be an acute angle triangle. Now in a right angle triangle, same thing, we have 2 acute angles already, we know it, because any triangle will have 2 acute angles. So one angle must be a right angle. Same for obtuse angle triangle, where 2 acute angles are obviously there and one angle must be an obtuse angle. The last thing which I am going to discuss in this tutorial is the exterior angle property of a triangle. Now as I have already told you in the beginning part of the video, that whenever we produce any side of a triangle, we get an exterior angle. Okay. Now the exterior angle property says that the exterior angle, any exterior angle of a triangle, equals the sum of the opposite 2 interior angles. Now let me write it. The exterior angle equals the sum of the 2 opposite interior angles. Now the exterior angle, this could be any exterior angle, that is any exterior angle we could have found, but for example I have shown this, I have taken this triangle ABC and I have produced this side BC to a point D. Okay. Now so the exterior angle ACD is formed. You see ACD, this is the angle ACD. The angle ACD over here, I am writing in short, angle ACD, this exterior angle equals the sum of the 2 opposite interior angles. What do you mean by opposite interior angles? The 2 opposite interior angles here mean this and this. Okay, this is the adjacent interior angle and these are the opposite interior angles. I hope you can understand that these are opposite to this. This is this interior angle is adjacent to this exterior angle ACD, and these angles A and B are opposite to the exterior angle ACD. So this angle ACD here equals the sum of the 2 opposite interior angles. The sum of means these are the 2 opposite interior angles, angle A and angle B. We have said that is the sum of, so we put a plus sign here. That is angle ACD equals to angle A plus angle B. Okay, I have drawn a different figure here. The property remains the same. I have deliberately drawn a different figure because to show that this could be applied in any way you draw the triangle. For example, here also I have taken this triangle PRQ or PQR, you can also call it. In this triangle PRQ, I have produced the side PR to a point S, and this exterior angle, here you see the name of the exterior angle will be angle QRS. I hope you can see this angle QRS. This is the exterior angle. This exterior angle will be equal to the sum of opposite 2 interior angles. So this is one angle, this is an angle which are the opposite interior angles to this. So that is equal to angle P plus angle Q. So I'll draw another figure over here just to show you in a rough way suppose I draw this exterior angle, so this will be equal to this plus this. So this can be done in any way you draw a triangle, right? So with that we come to almost the end of the video, because I have covered some very basic topics about triangles here. But let me tell you, a triangle has got many more properties which we are not discussing in this tutorial video. I'll discuss those properties in some other tutorial video. This is meant for those who have no idea about triangles, so I made it very simple, and only these properties or these definitions which I have given till now, I thought those are necessary for those who have no idea about triangles. So let me stop up to here. But one thing I must tell you, this comes to my mind, that triangle is a very important topic in geometry. Why? Because you see, you will be doing other chapters like circles. There also you will be needing concept of triangles. You will be doing quadrilaterals. There also you will be needing concept of triangles. You will be doing trigonometry. There also you will be needing concept of triangles. You will be doing mensuration. There also you will be needing concept of triangles. So triangles is a very important topic. So we have just discussed some basic properties of triangles here. The other properties I'll discuss in some other video. With that, I come to the end of this tutorial. Hope you have a good time. Do practice maths. If you have any kind of queries or question, please write it in the comment box so that I can see it, and I'll surely try to answer that. Okay, don't forget to subscribe to my channel, that is Easy Maths, and don't forget to press the bell icon for further notifications. Thank you. Have a nice time.